So for one, we are going to get into some more of a trigonometry and talk about radian and degree measure. So some things that we're going to look at today is describing angles, using radian measure, using degree measures to convert between degrees and radians, and then using angles to model and solve problems. So the first thing is angles and just understanding some vocabulary in terms of angles. So the idea is that an angle is a ray that's revolved or rotated around a certain distance. So your initial side is the starting position of the ray, as you can see right here. So if this was your initial side and you rotated it a certain distance here, then where you ended up would be your terminal side, right? And then these two, where the two sides come together, is your vertex. And we'll get into this a little bit more, but that angle that you rotated your ray becomes your angle measure, and we'll talk about that in terms of degrees and radians. So the end point, like we said before, is the vertex. So looking at this picture, this point right here where the two angles, the two sides come together, the initial side and the terminal side is the vertex. And we're usually going to deal with angles in standard position. So standard position means that your initial side is on the positive x-axis, right? And then you're rotating around the origin to wherever that terminal side ends up. And then that angle measure, that theta, is what we'll end up looking for. So positive angles, remember, are if you start in your standard position, which is right here on the positive x-axis. If you rotate counterclockwise, we have positive angle measures. And if you rotate clockwise, you will have a negative angle measure. So angle measures will use Greek letters, so alpha, beta, and theta. And sometimes, like when you were in geometry, you used capital letters. For the most part in this book, you'll just see those Greek letters, that alpha, that beta, and that theta. So you'll know if you see those Greek letters that they're talking about angle measures. So something else, another piece of vocabulary, is the word coterminal, right? And what that means is that coterminal are angles where their terminal sides end up in the same place, but their angle measures might be different. So for example, if I rotated positive theta this way, positive alpha, and negative beta this way, right? The terminal side here is the same. So for the sake of numbers, maybe we would say that this one we could say was 240 degrees, right? Which would make this angle beta negative 120 degrees, right? Those two angles are coterminal because if you were to start from that positive x-axis and rotate either one of those, you would end up in the exact same spot. The same thing with this next example. If you were to go all the way around the circle, so 360, and then we'll say maybe this is plus 45. We'll call this 45. So we'll say that alpha is 45 degrees, which means that beta would be 360 plus another 45, right? So that would be 405 degrees. Those two angles would also be coterminal because they're ending up in that same place. So the idea with coterminal is you end up in the exact same place even if your rotation is different. Moving on to the radian measure. So I was showing you things in terms of degrees, but when you're talking about angles, sometimes it will be in terms of radians. Right, so the measure of an angle is determined by the amount of rotation from the initial side to the terminal side. And one way to measure that is in your radians. Okay, so to define a radian, you can use your central angle of the circle. Right, so we would say, in this case, if you look, your arc length equals the radius when theta equals 1 radian. So your definition for radian measure, 1 radian is the measure of the central angle that intercepts an arc S equal in length to the radius r of the circle. So algebraically, it just would mean that if you had to find theta and you knew the radius, which is r, right, S is your arc length, and r is your radius. So if you did arc length divided by radius, you would get what that central angle measure is. And remember, going back to this slide, your arc length is just this measure here. It's that length of the arc that we're talking about. So you have 4 quadrants, remember, in your coordinate plane. Quadrant 1 starts here, right, where theta is 0. And in terms of radian measure, if this is 0, and if you went all the way around, you would get back to 2 pi. So if you think about your quadrants, the first quadrant from here to here is a quarter of a circle, right? So if you take the whole circle, which is 2 pi, and you divide it by 4, then this radian measure up here is pi over 2. And that's quadrant 1. Quadrant 2 is over here, right? This is quadrant 2. So if you think about this, you've gone halfway around your circle. So that radian measure is pi, right? Since the whole thing is 2 pi, halfway around would be pi. If you keep going another quarter, so now we're 3/4 of the way around. This is quadrant 3 over here. Down at the bottom here, you're at 3 pi over 2. And then in quadrant 4, you're over here and you get back to 2 pi. And you can see here it shows you your angle measures that are in the quadrant. So quadrant 1 has radians from 0 to pi over 2. Quadrant 2 has the radians from pi over 2 to pi. Quadrant 3 has the radians from pi to 3 pi over 2. And quadrant 4 has the radians from 3 pi over 2 to 2 pi. Okay, and then 2 angles are coterminal when they have the same initial and terminal sides. So that's what we talked about. So for instance, the angles at 0 and 2 pi are coterminal, as are the angles at pi over 6 and 13 pi over 6. A given angle has infinitely many coterminal angles. So if you were at pi over 6 for one of your angles, if you added 2 pi n, and we'll just say, for instance, 2 pi in this case, right? So if you were at pi over 6 is kind of right here. And if you went and added 2 pi to that, that means that you're adding another full rotation, right? So if you start here to get pi over 6 and then you go around all the way around again to get to here, that angle is going to be coterminal with your pi over 6. So looking at this first example, sketching and finding coterminal angles. So the sketch is already here for you, right? And we need to have the positive angle, which is at 13 pi over 6, and we're going to find a coterminal angle. So something that you need to keep in mind is your unit circle. And if we have our unit circle, so if we just do a quick sketch, and I know that you guys did this last year, but we might need a quick refresher. All right, so if we fill in those quadrants, okay, so again, and we get over here and we're, this is also your 2 pi, right? So this first one right here, if we get to right here, halfway between 0 and pi over 2 is pi over 4. So if we count, this is 1 pi over 4, this is 2 pi over 4. If we went to halfway again here, we would be at 3 pi over 4, 4 pi over 4. Right here, we would be at 5 pi over 4, 6 pi over 4. This is 7 pi over 4. And then back here, you're at 8 pi over 4, right, which gets you to 2 pi. So those are some of the angles. Those are your pi over 4s that you need. And then we also need our 30-degree increments. So those will be here and here, right? So 30 degrees, again, if we were to split this 0 to pi over 2 into thirds, So 1/3 of pi over 2 would be at 1 pi over 6. And then the next one would be at 2 pi over 6, right? But 2 pi over 6 will actually simplify to be pi over 3. So this is 2 pi over 6. This one right here, this is 3 pi over 6. Over here, the next one we would be at 4 pi over 6, which could simplify to be 2 pi over 3. Then here we're at 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, but 8 pi over 6 simplifies to be 4 pi over 3. This is your 9 pi over 6, 10 pi over 6, and then here you're at 11 pi over 6, and then you get back to your 12 pi over 6. Okay, so we've got kind of that unit circle. So we have a positive angle at 13 pi over 6. When you want to find a coterminal angle, really all you need to do, and you don't necessarily even need the unit circle, but you just need to add or subtract 2 pi. So let's say we're going to subtract 2 pi, right? Because that's a full revolution or a full rotation. So if we subtract 2 pi, we would say 13 pi over 6. We need a common denominator. So minus 12 pi over 6 would give us pi over 6. So pi over 6 would be coterminal with 13 pi over 6. So if we're at 3 pi over 4, if our angle is 3 pi over 4, in our picture, right, this is our 3 pi over 4 right here. In our picture, we're going to subtract, again, we're going to go the opposite direction. So let's subtract 2 pi and see where we end up. So if we have 3 pi over 4, right, because the idea is we're here, but then what we're doing is we're going from here back around, we're subtracting a full rotation. So subtracting, this is like our minus 2 pi right there. So 3 pi over 4 minus 8 pi over 4, right, with your common denominator. So you would get negative 5 pi over 4 would be coterminal with 3 pi over 4. They would end up in that same spot. All right, so this next one we have negative 2 pi over 3, right? So here we're looking at this angle, negative 2 pi over 3. If we added 2 pi to that, so we're saying we're going from here and we're going back around in the positive direction, 2 pi, where would we end up? So we have negative 2 pi over 3 plus 6 pi over 3 gets us to 4 pi over 3. So 4 pi over 3 is coterminal with negative 2 pi over 3. They would both end up in the same position, that terminal side would. All right, so then looking at your degree measure, again, degree measure, you can convert between degrees and radians. So 360 degrees is your full rotation of a circle, which is the same thing as 2 pi radians. So 180 degrees is the same thing as pi radians, kind of like we just talked about on that unit circle that we drew. So if you need to convert, right, converting degrees to radians, you're going to multiply by pi over 180. If you want to convert from radians to degrees, you're going to multiply by 180 over pi. So here's a picture of just where your kind of that unit circle that we talked about, the first quadrant, the pi over 6, pi over 4, pi over 3, and what those look like in terms of your degrees. So if you need something to refer back to, you could look at that. So for examples 2 and 3, we're going to be converting from degrees to radians and then from radians to degrees. So if we have degrees and we want to get to radians, then what happens is it's kind of like when you made those fences. You could almost think of making a fence, Right, so you need degrees in the denominator. So you need 180 degrees in your denominator and the pi in your numerator. So if you multiply that, you get 135 pi over 180, which simplifies down to 3 pi over 4. So 540 will multiply by pi over 180. Right, so we would have 540 pi over 180, which gives us 3 pi. And the interesting thing is 3 pi, if we just think about where that is, so as you're doing these problems, it might help it just might help to think about where that is, just to start getting used to that. So 3 pi, remember, if you were to count around, you'd be at 1 pi, 2 pi, 3 pi. So 3 pi would just end up over here, over on that side. So 3 pi is really coterminal with pi. If we want to convert from radians to degrees, again, so that means we want to get rid of the radians, right? If we were to think about the fence, we could put the pi in the denominator and the 180 degrees in the numerator, so that way the radians would simplify, right? Those would simplify, and you would end up with 180 divided by 9, which would give you 20 degrees. So same thing here, we would multiply by 180 over pi. Your pi's simplify, and you end up with 480 degrees. Going back to geometry, just the reminder of complementary angles add up to 90 degrees or pi over 2, and supplementary angles add up to 180 degrees or pi. So just keeping that in mind. So here, if we're finding complements and supplements of each other, degrees, you guys are probably really good to go, right? So if we wanted to find a complement of 72, we would just do 90 minus 72, right? And we would get 18. And to get your supplement, we would do 180 minus 72, and we would get 108, right? So 48, the complement of 148, if you do 90 minus 148, you're actually going to find out that your complementary angle is a negative rotation, right? Because you have to get back to 90. So it would be negative 58 degrees. And your supplement, we would do 180 minus 148. And you would get 32 degrees. Okay. So we'll do the same thing with the radian measures, but you have to use the pi and the 2 pi. So complementary angles are 90, which is, complementary are 90, so that's your pi over 2. So 90 degrees would be pi over 2 minus 2 pi over 5. Okay, you need a common denominator, so we would have to say 10 pi over 5 minus 4 pi, not 4 pi over 5, sorry. We're going to just erase that whole thing. Don't write that down. I reverse switched that. Our common denominator is 10. So we have to have 5 pi over 10, sorry about that, minus 4 pi over 10. So your complementary angle would be at pi over 10. Supplementary angles are 180 degrees, which is pi. So we would have to say pi minus 2 pi over 5. So common denominator would be 5. So 5 pi over 5 minus 2 pi over 5 would give us 3 pi over 5. That would be our supplementary angle. So we can do the same thing for D. If we have pi over 2 minus 4 pi over 5 right? Our common denominator is 10, so we would have 5 pi over 10 minus 8 pi over 10. So negative 3 pi over 10 would be our complementary angle. That's what we could add to 4 pi over 5 to get back to pi over 2. And then for our supplementary, if we did pi minus 4 pi over 5, so again we have 5 pi over 5 minus 4 pi over 5, we would just get pi over 5 would be our supplementary angle. And then we have linear and angular speed. So again, remember that your radian measure is theta equals s over r, where s is your arc length. So if we were solving for arc length, if we were solving for this s, we would have to multiply both sides by r. So the arc length, s, is r times theta, where theta has to be measured in radians. So if they give you theta in degrees, you'll have to convert that to radians before you actually calculate your arc length. So here we have a circle has a radius of 4 inches. So if we were to just kind of start to think about what we have here. So our radius is 4. We want to find the arc length. So we want to find S when our central angle, our angle is 240 degrees. Right, and remember our arc length formula is S equals R theta, but theta has to be in radians. So we're going to have to take our 240 and convert it into radians. Right, so 240 over 180, or 240 pi over 180 is 4 pi over 3. So for our angle measure, in our arc length formula, we actually have to use 4 pi over 3. So our arc length will equal the radius, which is 4, times the angle measure, which is 4 pi over 3, which gives us 16 pi over 3, right? And they told us our radius was in inches, so our arc length is also in inches. So that would be your exact value. If they want decimals, we'll go to 3 decimal places, so we would say 16.755 inches. Your linear and angular speed, your linear speed is just your arc length divided by time, right here, so S over T. Your angular speed is your angle divided by time, and again, remember that your angle is always in terms of radians. So if they give you the angle in terms of degrees, then you need to change it into radian measures. So here we have the blade of a wind turbine, or the blades of the wind turbine are 116 feet long. So they don't tell us necessarily what that is, but if you think about this wind turbine, right, going around, what that means is that these blades, this 116 feet long, that's your radius, right? So you're going to have to pull that information out, that that's the radius. And the propeller rotates at 15 revolutions per minute. Right, so if we need to find the angular speed in radians per minute, remember that our angular speed, right, is theta divided by time. Okay, in this case, if we have radians per minute, our time is going to be 1 minute. And we have to figure out how many radians is 15 revolutions in 1 minute. So 15 revolutions is 15 times around your circle. Right, so if 1 time around the circle is 2 pi, 15 times around the circle, we're looking for theta here, 15 times around would be 30 pi. Right, so we would say our theta is 30 pi. All right, so our angular speed is just 30 pi and your label is radians per minute. Okay, and then your linear speed, remember, is your arc length over your time. So we're going to have to find our arc length, right? And our arc length, remember, is r times theta. So instead of s, I might say r times theta over time. I know my radius. Remember, we said the radius was 116. We know that our arc length, or not our arc length, I'm sorry, our angle measure from part A is 30 pi. And our time is still 1 minute, right? And remember that this arc length is in terms of feet. So this is our feet per minute right now. So if we do 116 times 30, if we were leaving this exact, we would say 3,480 pi, and our label would be in feet per minute. If we were writing this as a decimal, so if we multiplied 3,480 times pi, we would get 10,932.742 feet per minute.